Okay, Assalamu alaikum. Bismillahirrahmanirrahim. In last class, we have discussed the fundamentals of BGP. What is BGP? Why should or why should we use BGP and others BGP attribute? BGP attribute is used for selecting the best path. So today test we basically testing a multiple lab basically. It can be regarding IBGP or EBGP. Okay, so I already discussed in last class what is the difference between IBGP and EBGP. In a autonomous system, if you make BGP, it can be it will be IBGP, and if you make BGP between AS, so that will be EBGP. Okay, so IBGP is used within an autonomous system, whereas EBGP is used between autonomous system. Okay, it's the normal or general statement. When you configure IBGP, we consider loopback interface for IBGP peering, because see here it's a simple topology. Three router is connected with each other, and IBGP is running between among these three routers. So if just consider one route, one route is here. I'm getting this route through BGP. It can be EBGP. Route is automatically advertised in router 2. Also automatically advertised to router 3. If I consider physical interface IP for IBGP. But if one link goes down, if this link goes down, so this is IBGP, again IBGP. So this R1 route will come router 3, but will not advertise towards router 2. So that is the difficulties. In that case, you can configure IBGP to make full mesh, when you create the IBGP. If you consider loopback interface, just consider here loopback interface. It's a loopback interface. Every router have loopback interface, and you configure IBGP between loopback interface to loopback interface, loopback interface to loopback interface. In that case, if this link goes down, loopback interface will be reachable through IZP. That means you run here IZP. It can be ISIS, it can be OSPF. Loopback interface IP will be reachable through IZP. If loopback interface reachable through IZP, then you configure IBGP. So if direct links goes down, it will automatically travel through alternative link, because BGP is loopback to loopback, no dependency with point-to-point IP addresses. In that case, we configure IBGP. We configure IBGP using the loopback interfaces, not use the directly connected interface IP addresses. So loopback and interface peering eBGP sessions are usually established using the IP address of the physically connected interfaces. IBGP sessions are usually established between loopback addresses. Uses ICP to maintain session regardless of the physical topology. Okay, so that is recommended. Loopback and interface pairing, another statement. Each router along the path between BGP speakers make consistent routing decision about packet forwarding. If you configure IBGP using the loopback interfaces, you have to maintain one thing. You have to consider full mesh. It can be manual full mesh. It can be manual full mesh, or it can be a route reflector solution or BGP configuration solution. Okay. How route propagate in IBGP? When you configure IBGP using the loopback interfaces, see here, route X is coming from 64502 and I'm in 64503. So here BGP is eBGP. So I'm getting route through eBGP, and this route will automatically advertise our IBGP neighbor or IBGP session. Okay, everything is every router in IBGP is connected. Peer is loopback. So this R1 will make BGP session with R2 loopback. R1 will make BGP session with R3 loopback. So if you have three routers, you have to make two BGP session. Two BGP session. So if you have 10 routers, you have to make 9 BGP sessions. 9 BGP session to make full mesh. Okay. To make full mesh, you have to ensure. Otherwise, full mesh, you will not get prefix. Route propagation. This is the way of route propagation in IBGP. Using route reflectors or configuration can alleviate the full mesh requirement. That means you have lots of router here. Consider you have 400 router in AAS, or you can consider thousand of router in AAS. In that case, just consider 100 router. In that case, you just add one single router. You want to add one single router. This router, you have to make 100 BGP sessions for IBGP. If you make configure regarding customer, that will be eBGP. But you have 100 router, you want to add one new router in your network, you have to configure 100 BGP session. That is huge. That is huge. In that case, you can choose another solution, route reflector solution or BGP configuration solution. If you use route reflector section solution, so you can consider primary and secondary route server for failover. Every route server client, every or others router will just make BGP session with route server, primary route server and secondary route server. No need to maintain BGP session between route server client. Okay, in that case, your configuration will be reduced. So you can It's recommended for large environment, but if you have only two routers or three routers, you can continue with IBGP full mesh, no issue. But if you have more than this, okay, more than this, you have to consider route reflector solution. So BGP default advertisement rules, just see here, route X or prefix X is automatically advertised through eBGP. You will get no issue. So this S is 64501. This S have two routers. Inter between two routers, IBGP session configured here. So eBGP then IBGP, it will work automatically, no issue. Then again eBGP, automatically prefix coming here. Again eBGP, automatically prefix coming here, no issue. So here prefix coming through eBGP, here prefix coming through eBGP, then goes to IBGP, 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 IBGP. So if you want to just check, just this physical link is down. So this prefix must become through this link. If you make loopback, if you use loopback interface for IBGP session. So normally you just configure here IBGP using the loopback interfaces. When one user is connected here and want to go or want to raise this prefix, normally traffic goes like this. Traffic goes like this. Okay. If one link goes down, traffic will automatically switch over to IBGP session and the traffic will forward or follow this path. Okay. This is happened automatically. Default BGP advertisement rules. Here, just consider three statements. One statement is IBGP advertised route learn from eBGP. First statement, eBGP advertised route learn from IBGP or eBGP. Second statement, and third statement, but IBGP does not advertise any route learn from IBGP. This is the restriction. Okay, so everything is allowed, only this is not allowed. So if you just remember this statement, other will be allowed. Okay, simple. Now we'll discuss next hop. Now we'll discuss next hop. So what is next hop? Next hop is just consider here, when you set static routing from here, you want to go internet. So you just make your default route and your next hop will be this IP address. If you consider from this router, okay? So this will be the next hop. BGP also use the next hop attribute, and this is the mandatory attribute. IBGP next hop propagation. By default, IBGP peer do not change the next hop for routes received from eBGP peers. When IBGP peers are getting route through eBGP peers, so when sending this route towards IBGP session or IBGP peer, next hop automatically not change next hop automatically. So in that case, for next up reachability, you can configure IGP, adding the upstream interface IP address in your IGP to reachable this interface IP address or next up. This will be one solution, and another solution is the policy. You can make policy to change the next hub. So policy is a better option in production environment. Okay, so go to our lab. Say here, take tree router, Juniper. mm, Three, or you can consider four. Interface, number of interface, consider eight. Save, two router. And this is Juniper router, or this is BMX1 and BMX2. And consider here consider here this three router is number 64513, and this router is number 64512. So it's different is. So here we have to configure the eBGP, and here you have to configure iBGP. Okay, so making this lab for better understanding. Interface J. Okay, so set here, duplicate ASN AS 64512, get, and this three router AS is, you can use custom shape, square background, no need. Okay, text custom shape, this is the border background. Just considering separate organization, send to back. Okay. This is another organization, 64512, and this is 64513. Okay. Start. Just a minute. Okay, now we create a lab to check IBGP next hop propagation. So just go lab. It's very straightforward and simple lab. One router is AS64512 and three router is 64513. Okay. Default user is root and password is root123. Root root123. Root 3. This router have some default configuration. So clear the extra configuration or just delete unnecessary configuration from here. Delete the interface uh, and you can set the host name. Host name is PMX1. That's it. Commit. So something will be for router 2 and others router. It will be BMX2 and commit. BMX3, BMX4. Okay, so first we choose here P2P IP and loopback IP address. P2P can consider here 172.168.0.0/30. Get consider here 10.0.0.0/30. Get and this here 10.4/30. So you consider here loopback interface. Loopback interface will be get 1.1/32. This is loopback interface for BMX1. Okay, and duplicate 1/32. This is loopback interface for BMX2, BMX1. Duplicate. So this is one. This is two. Another one is three. So it's your IP planning. Now start your configuration starting from BMX1. Set interface hello0 unit 0 description. Go back and set the IPv4 IP address. INET address 72.16.1.1/32, and interface IP will be set interface GE-0/0/0 unit 0 description. Connect with BMX2, and IP address will be family INET address 172.16.0.1/30. So IP address configuration has done. Show interface starts. See here, interface IP address setting done, and I use a loopback. Loopback interface IP address is this. Okay, show out. After configuring interface IP addresses, interface IP address will be installed in INET.0 route table because it's a IPv4 address. If you configure IPv6 address, and that will be stored in INET 6.0 route table. Okay, Juniper use INET.0 for IPv4 unicast. So I configure here one interface IP address in Z0/0, and another interface is loopback, and make the route table accordingly. BMX2 set interface hello0 unit 0 description. Go back. Family INET address. Loopback IP is 10.1.1.1/32, and the physical interface IP set interface ZE-0/0/0, this interface, and this interface unit 0 description. Connect with BMX1. Family INET address 172.16.0.2/30, 0.2/30, and another interface is connected with BMX3 Z0/0/1. So Z0/0/1, this interface connect with router 2 sorry, router 3, and this interface, the IP will be family inet address. IP will be 10.0.0.1/30. IP address assignment done. Check the route. Yes. Then go to PMX3. Set interface. Hello 0, init 0, description, and the loopback IP is 10.1.1.2, 10.1.2/32, right? You can check your configuration. Should display set command. This is your loopback interface and the physical interface IP address assignment. You can check from routers. Okay, so BMX3, I'm setting now loopback interface IP address 10.1.1.2, and it will be basically description back, and family inet address will be this one. Okay, set interface. One interface is ZA-0/0/1 unit 0 family inet address will be 10.0.0.2/30. Interface description will be BMX2. And the interface is connected with BMX4. Interface is J0/0/2. So interface 2 is connect with router 4, and IP address will be family inet address. IP address will be 0.5. This 0.5/30. Okay. Display set. Run show out. Yes. And last one. Set interface. Hello 0. Unit 0. Family inet address. Address is 10.1.1.3/32, and you can set here description and the loop back. Okay, set interface. Your one interface is connected with router 3. Interface ID is Z-0/0/2. Okay, and unit will be 0. Description, connect to it BMX3. IP address will be unit 0 family inet address. IP address will be 10.0.0.5 and then 6/30. So that's okay. So display set, you can check your configuration and IP address is installed in route table or not. Check the route table and it received. Okay. Now we configure BGP. So for BGP, and just BMX1 is connected with S64512 and other router is in 64513. When you configure BMX1 and BMX2, it will be eBGP and others will be iBGP. So first, make the eBGP session. First, configure, edit, protocol, BGP, edit protocol BGP. I'm starting with group. Group, you have to mention the group name. So you can set the customer name here, but here there is no customer name. The identification is the AS number. So I use here AS number. AS64513 will be my neighbor. I'm configure eBGP in BMX1. So set neighbor. What is my neighbor? My neighbor will be 172.16.0.2. Say here, my neighbor is 172.160.2. This is my neighbor. So I mention here the neighbor information and just make the commit. See here, I'm getting error message. In BGP section, error in neighbor of group S64513 must define local autonomous system when enabling BGP configuration checkout failed. So if you create any BGP session, we have to mention the local autonomous system number. So set routing options autonomous system number. My autonomous system number is 64512. Okay. Then again go to my BGP group and set commit. See here BGP again. I will again get error. Again see here the error. What is the error? Error in neighbor this of group name is this. Pair S number must be configured for an external pair. If you configure the external pair means eBGP and internal pair means IBGP. By default, when you configure BGP, by default router detect it will be eBGP. In that case, message type is like this, external pair. Or you can mention here, set type will be external if you configure eBGP. Type will be internal if you configure IBGP. So you can set here external. Okay. So you have to mention the neighbor AS number. You have to mention the neighbor AS number. So how to set the neighbor AS number? Set neighbor 172, and there is multiple option here. Okay. There is multiple option. We need to configure the PRASN. So what is the PRASN? See here, PRAS. Autonomous system number in plain number or higher 16 bits or lower 16 bits is the format. So command keyword is PRAS and set the PRAS number. I'm in 64512. My PR is 64513. So set here 64513. This is my PR. So set the commit. Commit done. Your configuration succeed. So this is the minimum configuration for eBGP. You have to configure or you have to mention two things. One thing is your remote peer address, and you have to mention the peer ASN, peer address and peer ASN. Okay. You can mention here set router ID, routing options, router ID. My router ID is 172.16.1.1. This is my router ID. Why? Because if you configure router ID as an interface IP address, interface can be goes down. In that case, your whole routing process will reset or rebooted. Okay. So in that case, it is vulnerable. So I choose here the loopback IP address. I configure here loopback IP addresses and set the loopback IP address as a router ID. So loopback interface will not goes down. If your router goes down, your loopback interface will goes down. Otherwise not. Okay, that's fine. So see here. Our simple BGP configuration, a BGP configuration, we need to set the router ID. We need to set the local autonomous system number. We need to set a remote or peer address and peer is. Similarly, from VMX2, I want to complete the BGP session. So if I run show BGP summary, this command will show you your configured BGP status. Your configured BGP status. Status is active. That means BGP yet not complete the TCP session. TCP session yet not completed. That's why stat is active. Okay. So next, go to BMX2 and configure eBGP first. So first, you have to set the autonomous system number. Set routing options. AUTO autonomous system number is 64513, and the router ID will be this router loopback address. This router loopback address is this, and edit protocol BGP group. I want to make BGP session OS 64512. So BGP group name here is 64512. So set type eBGP, set neighbor. My neighbor will be 1. My neighbor will be 1 and my PRS will be 64512. 64512. That's okay. Set the commit. Now check again. Now BGP is not up. Yes, BGP now up. BGP now up for 8 seconds. I'm not getting any prefix. First one is active, second one is receive, and third one is accepted, and last one is damped. So my BGP session is up. If you want to see detail here, neighbor, and place the neighbor here, and you can see here the BGP status. This is the peer information. This is the peer information. I'm in PMX1. My peer is 0.2 and my PRS number is 64513 and local IP is 0.1 and they are using the TCP port 179 to BGP communication, and my local AS number is 64512. This is peer information and this is the local information. And type BGP type is external. That means eBGP and state established. BGP established. What is the last state? Last state was often confirmed. BGP used the hold time 90 seconds for Juniper and BGP route preference value 170 for Juniper. But if you look into Cisco, the administrative distance for eBGP will be 20 and for iBGP administrative distance will be 200. So there have some difference. Okay. Juniper default use 90 seconds as whole time, but Cisco will use 180 seconds. There is no flaps in current BGP. PRID 10111. This is the loopback, and this is the local ID. This is also the loopback. BFD not create, keep alive interval. We use that keep alive interval, and keep alive interval will go every 30 seconds periodically. And this is the others information. This is the exit interface. You configure here iNet unicast, IPv4 unicast for IPv4 communication. Okay, so this is the NLRI, BGP NLRI, and this is your prefix information. This is your prefix information, and this is your message information. Message sent and received. Table inet.0 and active prefix says nothing, receive prefix says nothing, accepted prefix says nothing, suppressed due to damping, nothing, advertised prefix says nothing. Nothing happened here. No prefix received, no prefix advertised. Only we are making the BGP session. Only we are making the BGP session. And now BGP established. So if I see here, run show route, there is no route coming from BGP. Coming from BGP, there is no route here. Okay. If I make, if I want to advertise one prefix from BMX1, so set routing options static route. I make here 209.165.0.0/24. Discard I origin or making the pull-up route to advertise towards PHP. So you can set your preference. I set your preference 250. Run show route. This is my public prefix for this ASN. Just consider it's an example. So new, it's a static route. Consider here, it's a static route. If you want to advertise another routing information source route towards BGP, so you have to maintain the policy. You have to maintain the policy. So cite your policy, edit policy after policy statement. I want to advertise this prefix towards 64513. So my policy name can be is 64513 IPv4 out. And you allow this prefix set from 100 from route filter. I'm allowing this prefix accept and set the action accept. Other than this will be reset. So I am allowing only single prefix here. Okay. Uh, Now attaching this policy in BGP group, edit protocol, BGP, BGP group, and group name is 64513, and set neighbor 172, export, and attach this policy. Say here, the coverage. Say here, you will get one prefix from BGP peer. This is your prefix. No one from BGP routing protocol. I'm getting one here. Okay. So this is my destination prefix coming from 64512. The origin code is I. This prefix is normally um, create the flop route and advertise through policy. That case, I will get here origin code I. Local preference, it's a default, and this prefix is coming through BGP, and the default preference is 170, and this is the next step. I'm in BMX2. I'm in BMX2. BMX2 interface IP address is 172.160.2, and my next hop is 1. See here, in eBGP, next hop automatically change. Next hop automatically change. No need any policy, no need to do anything. But if you configure IBGP, you have to consider. You have to consider this. So go to the IBGP session now. So when you make IBGP session, you have to consider the loopback address. You have to consider the loopback address. Otherwise, what will be the problem? If you make IBGP session with the physical interfaces, just create the problem here. Edit protocol BGP group. Your group is IBGP IPv4. You can mention here type internal, set neighbor. If you just for checking, you make neighborship with physical interface IP 10.1.0.0 neighbor 10.0.0.0.2, and remote is sorry PRS number is 64512, same as number, sorry, 64513. This is the IBGP session. PRS will be same. So that's all. Now go to VMX3, show display side. Say here, just IBGP and IBGP session. We're just making neighbor. If we set your neighbor will be 1. Here interface IP 1 and this interface IP 2. From BMX2, my neighbor is 2. From BMX3, my neighbor is 1. Alternative. Another session is connected here from BMX3 and BMX4. So in that case, my IP will be, this is 5 and this is 6. So this will be 6. The neighbor is here. Commit. Commit. I'm getting error here. Local autonomous system not set here. Okay. Set routing options. autonomous system routing options. AUTO autonomous system 64513. This autonomous system, same for router 4 and router ID. Router ID will be 10112 and router ID will be 1013. So need to set the neighbor router 4 to router 1. Set neighbor. Neighbor is 10.0.0.5 and peer is 64513. Okay. See here, then my route is 64. This is the EBGP route. Just specify the route. See here, I'm getting this route from 64512. It's installed in inet.0 route table. There is no problem. Now checking the BGP session. Now show BGP summary. My BGP is up. Okay, both ABGP and IBGP from router 3, BGP up. Okay, and last router, yes, BGP up. But problem is I'm getting route in BMX2, but when checking this route from BMX3, this route not in route table. This route not in route table. Another router 4 have not route in route table. So what is the reason? What is the reason? So I'm just checking your hidden and see here, there is no next hop. There is no next hop. There is no next hop. If you see here expensive and say stat hidden, route is hidden. Why? Next hop type unusable. Next hop is not traceable. Next hop is not traceable. Okay, that's why will not get this traceability information and route is not in your inet.0 route table. This route is hidden because of next hop. Because of next hop. So how to solve this? You can solve this using IGP. You can configure IGP and set this interface IP. Set this interface IP in your IGP. Then IGP will advertise these prefixes to your neighbor router. But this is not the recommended solution. You can set a policy. You can set a policy to advertise your prefixes. Okay. So create a policy here. Create a policy here. Edit policy option, policy statement. Next up, next up, sir. You can try like this or can convert underscore. Next up, sir. I will go. set term, you can assign any term here. Set term 100, then action will be next stop, then next stop, and next stop will be cell. Use the local address as the next stop address. Okay, so I'm using here next stop cell policy. Comment this one. Edit protocol BGP group S64512. Sorry, IBGP for IPv4, and set. You can set your policy in your group. So set export. Next stop SAP IPv4. Then set the commit. So go to BMX 3 and see here route is in your IPv4 route table. And see here the next stop. Yes, this is my next stop. From router 3, my next stop is 10.0.0.1. Yes, it's correct. But in router 4, nothing. But in router 4, there's nothing. So I make here this policy in router 3 and router 4. Show as display set. I make this policy in router 3 and also router 4. Commit, commit, and attach this policy in IBGP group. Commit. See here, what is the status of route now? This is my route. It's okay because it's coming from eBGP. In router 3, this is IBGP. Getting route from eBGP, this route automatically advertise through your IBGP peer. This is IBGP route. And again, see here IBGP. So IBGP route again not advertise another IBGP peer. That's why I'm not getting this route in BMX for route table. This is the reason. So this is the difficulty. Basically, this is the difficulty when you configure IBGP session with physical interface IP addresses. So if I convert this from physical interface to loopback interface, that will make sense. Rename neighbor 10.0.0.2 to neighbor. My neighbor will be 10.1.1.1.2. 10.1.1.1.2. This is my first neighbor. From router 2, this is my first neighbor, and 3 will be the second neighbor. 3 will be the second neighbor. Oh, 3 will be the second neighbor. So my reference will be now this. So see here, oh, just renamed. Okay, no issue. Now we can copy 10.1.3 to neighbor, and that is 2. Okay, insert neighbor 2 before neighbor 3. You can synchronize, or you can sort like this. So I'm in router 2. I'm just configuring. I have configured two IBGP session using the loopback. So here, say the three router. So you have to make two IBGP session to create the full mesh. Okay. So we configure them in router 3 and router 4. BGP group. BGP group is BGP IPv4, and there is two neighbor basically, but rename need to rename these two neighbor. First one is 10.1.1.1, and second one is 6.6.2.3. So I'm in 2, my pair will be 1 and 3. Simple. 1 and 3. All right. Edit protocol BGP group IBGP IPv4 single neighbor. So rename neighbor this to neighbor. I'm in router 3. My neighbor will be 1 and 2. 10.1.1.1 is the first neighbor, and copy neighbor 10.1.1 to neighbor. Second neighbor will be 2. So that's all. This is the one neighbor, and this is the second neighbor. Good. See here the BGP status. BGP will be up or not? What is your response? IBGP will establish here. Is IBGP established here or need anything? Guys,
Yes,
IBGP down?
establish.
No, IBGP down. 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 Because you have no IGP here. No IGP configured yet. Okay. This router cannot trace loopback interface of router 3 and router 4. There is no way. Need ICP routing protocol to raise another router loopback addresses. Okay. So need to configure ICP. For ICP, we can choose OSPF. So set protocol OSPF area 0 interface. Interface is loopback 0, and this is pass. Okay, and interface, I'm in router 2, my interface Z0 by 0 by 1. This is my domain. So ZE dash 0 by 0 by 1, and interface type is P2P. We already discussed regarding this. Set the commit on loopback interface, and P2P interface will be in ICP. Sure, display set. Configure here. Another is interface. Router 3, 1 and 2. 1 and 2. Correct. And for router 4, 2. Show step neighbor. Yes. Neighbor up. Ensure SPEP neighbor up and send. So check now BGP status. Ensure BGP summary. Yet now active. Yet now active. Yet now active. So what is the reason? What is the reason? Anyone? This is my BGP configuration. So let's plus that. Mass. This is my BGP session. So what is the wrong? Find. What is the wrong? Stay here. You declare this is your neighbor. 10112. 10112 is your neighbor. 10113 is your neighbor. First say 10112. Run ping 10112. Yes, reachable. Free reachable. The neighbor is reachable, but will not make neighborship. Will not make neighborship because you declare here my neighbor will be 10112. When sending the TCP request to neighbor, BGP default use the interface IP, connected interface IP. Okay, so this router sending BGP request and just source IP is 10.0.0.1 and the neighbor is this. In router 3, I am declare this will be my neighbor. But when sending the BGP request, they use the source IP is directly connected point-to-point IP address. That's why BGP showing down. So in that case, you have to mention the local address. You have to mention here for IBGP, you have to mention here local address. So what will be the local address? Local address. I'm in router 2. My loopback IP is 10.1.1.1. This IP will be my local address. For neighbor 3, same. Commit. So you can set this local address in your group. If you set anything in your group directly, so that will be applicable for all neighbor under this group. Local address and this router loopback IP is 2. Last one, 3. That's done. Now check BGP session. Up, up, and the last one, yes, up. So every BGP up. Just check the route now again. Again, check your route. Is it okay or not? In router 2, it is okay. Router 3, yes, it's okay. Router 4, yes, it's okay. Because of loopback interface BGP session. Clear? So we need policy in IBGP to change the next step. So go to further. Configure BGP. Already we configured the BGP session. This is the topology. We're already doing this. This is the sample configuration. How to set the router ID, how to set the AS number. Okay. And deduce next of cell. Yes, next of cell. You have to use next of cell. Number one, you have to use local address in IBGP session. This is the number two criteria. See here, internal, that means IBGP. See here, local address. Okay. But in eBGP, no need local address. You can use, but no need. This is optional. Okay. Configuring BGP, and this is the PRS. How to set the PRS number? We already configured this one and set some configuration and getting some error and fix this one. We already completed. This is the next of cell policy and how to apply the next of cell policy in IBGP session. We already do this. Okay, this is the policy and how to apply this one. This another policy. This is from a static route and set the policy and matching this route and advertise those prefixes. I already show you. You can add policy in under protocol. You can set policy under group. You can set policy under neighbor. So neighbor will be the more specific, group less specific, and protocol is more less specific. So you have three options or three locations. You can apply your policy. Okay. Applying policy, you can apply your policy for import filtering, or another is export filtering. When you receive something from your neighbor, you have to maintain the import policy. If you send any route or prefix towards your neighbors, you have to maintain your export policy. Okay. This is simple. This is the BGP session, BGP neighbor. How to check the BGP neighbor. Okay. So this is the monitoring session. Basically, I already show this one, show BGP neighbor. Okay. Show BGP neighbor others parameter. I already shown. Confirm none. Everything is show command. Everything is coming from show command. Basically, two command is here, show BGP summary and neighbor. Okay. This will be the part two. Advertise route, receive route. Okay. Some more troubleshooting commands. I'll show you now. Okay. See, first one. And show BGP summary. This command basically show you the peer. This is the peer address. This is the peer is the number. This is the communicating packet. You just receive this packet from your neighbor, and you sending this number of packet. If BGP flaps, you will get the number here. And this BGP is up for 35 minutes and 24 seconds, not getting any prefixes from customer or AS64512. If you can check from here like this. Okay, this is very important. First one is, see here, this first one is active, second one is received, and the third one is accepted. So Accepted prefix will be active or not active. If you make any filter, if you make here any filter, so uh, that by using this filter, you can filter the receive prefixes. Okay, so if you want to check and show route advertising protocol BGP, this pairing, I'm sending nothing. Okay, but receive, if you want to check the receive, yes, I'm receiving single prefix. If you want to send any prefix from here, like set just for checking routing options starting route 209.165.100.0/24 discard preference and preference to, so it says static route, so need a policy edit or set here, set policy option policy statement AS 64512 IPv4 out route. This is a policy tab 100 from route filter. You're just matching this prefix 100.0/24 exact and set the action here, accept and from 1000 then reset and set this policy, set protocol BGP group. Your BGP group is 64512 and set the export command. Export is as in 64512 IPv. Right. So if you just now check, see here on prefix is here. If you just check the advertise status now, receive advertise. Yes, this prefix is advertise. So you can check which prefix advertise from your router and which prefix you receive from your neighbor. Okay, just use this command. So if you just filtering prefix like this, edit like this, you just filtering your prefix. So edit policy option policy statement deny all. Just set here, set 1000, then reset. Everything is resetted here. Okay. Set protocol BGP group. Your group name is AS and the input. If you want to filter prefixes which is coming from neighbor, okay, in that case if you want to filter, set the import policy, just set here deny all. Okay, commit, say the BGP summary, say here active is 0, one prefix received but not accepted, not accepted. In that case uh, prefix is not accepted. In that case prefix will not be inactive route table. Okay, so if you want to see like what is the reason, run show route 209.165.100.0/24. Say here route is hidden. Okay, why route is hidden? Say here route is hidden. Everything is okay, but route is hidden, not installed in route table. So if you just set here extensive, route is hidden because route is rejected by import policy. Route is rejected by import policy. Damped means if your BGP session frequently up and down, you can cite here, you can configure here damping. In that case, they are counting if this route is coming because of damping, violating the damping parameter. So in that case, your prefix will be in damping list. Basically, we configure damping when your circuit is unstable. It can be for it can be for your router physical issue, or it can be for your link is not stable. In that case, we use damping. So that's all. I think that's all for today. Um, I discussed both eBGP and IBGP session, addressing policy, export and import policy, and some monitoring commands, and configure both eBGP and IBGP session. So, have any query? Have any query for today's session? Nothing. Okay, that's all. Um, Stopping today now.